Oracle, you've come to the right place if you want to find out more about Docker, Kubernetes, Autonomous Database, and Istio. This will be a workshop session, so expect some code. Alex will also make a short break after 50 minutes, so you can stretch your legs.
Yeah.
So, Alex, welcome.
Thank you very much, Urban. Thank you very much for the intro, and thanks everyone for having me here, at least virtually, right? I'm really honored to be basically to share the agenda with such amazing speakers. So let's jump directly to it, because we have quite a long session, and I understood the hard way that you know, I need to grab your attention within the first 3 minutes. So let me share my screen, and please, if someone can confirm that you can see my screen.
Yeah, it's okay.
Perfect. Thanks a lot. Okay. So the session we're going to present today and what I'm going to cover, you know, it's quite obvious what we're going to cover: cloud native development inside Oracle Cloud Infrastructure. But I think, and we actually worked a lot on this, I think we're going to do it in a very interesting, and you know, I'm going to try to basically trigger your curiosity. And because I want to grab your attention from the beginning, let me jump directly to the demo part. We will start with the demo. I'm going to present exactly what we're going to see today, right? And only after that, we're going to come back to the slides. And trust me, I'm going to jump a lot through the consoles. I'm going to show a lot of live demos, right? We will use basically some PowerPoints just in order to have a theoretical part, but I will try to keep it as low as possible. So let me jump here to my environment. Don't worry about the code at this time. And look, in front of you on the screen is basically our demo. Don't worry, I'm not trying to sell you any kind of cat food. I'm not trying to sell you any kind of, you know, retail practices. We at Oracle, we deliver cloud solutions and we deliver technology solutions. So it's not about the usage basically of this application. It's about the application itself. So what you have in front of you, it's called MuShop. It's a reference. It's a cloud native reference application which we've built, incorporating most of the best practices and the technologies which are very popular nowadays when it comes to cloud native. It's fully functional. So let me just do some clicks here in the interface. So you can see that this, although it's a sample application, it's quite works quite well. So you can see we have basically a profile page. This is an e-commerce. And if you're curious why we chose, you know, why we call it MuShop and why we see cats all over the place, fun fact, this was delivered by our brightest team, Oracle A team, and it was implemented using cats, because if you want to be popular in the internet nowadays, you need to use cats. You have cats videos all over the place. So we thought about, you know, what if we are going to create a shop, an application for cats? Probably this is going to be quite a hit. And to be honest, it quite is. And there is also another thing which we're going to cover about the naming, but getting back to the application, right? So we have an e-commerce application where you can see basically your profile. I can go here and scroll basically to see, you know, my personal details. I can enroll an address for the shipping. I can add payment solutions basically in the application. I have a search option in order to basically search for specific products if I'm searching for something very specific, or I can go ahead here in the catalog and explore the products we have. And we haven't implemented, you know, all kind of we haven't implemented all cat related products, but we have certain categories just in order to be as close as possible with the real thing. So for example, I'm going to have here, if I'm going to go to dry food, I'm going to have several items. I can add it. So I have a cart being implemented in my application. I can check basically the cart, and if I want, I can proceed to the checkout, or if I want, I can go ahead and search for different other products. So why I'm showing you this, what we have here, and if you can see here in the browser, this is a public IP address of a load balancer being provisioned in Oracle Cloud. Our entire presentation today is going to cover this application. This application is running in Oracle Cloud Infrastructure, is being accommodated by a Kubernetes cluster, and we have incorporated in it multiple services. Some of them were already mentioned and presented by Robert, but we are going to take a closer look to things like Kubernetes, function, streaming, all of them, they are being deployed in the back of this application. And once we are going to go to the demo part, we are going to show all of them. Keep in mind, our goal today is basically with this presentation is for you to understand the concepts, right? It's for you basically to understand the concepts, because this code, the source code and everything you're going to see today, it's publicly available and it's going to be shared with you. So you can use what you already mentioned. We have the option of using an always free tier, and we have the option of Oracle free trial. So if you're going to start your cloud native journey, you can go ahead using our applications, which incorporates all of the best practices, and start learning by using this as an example. This is our goal. And what we're going to do today, we'll start with the theoretical part in which we're going to explain what cloud native is and what is our understanding of cloud native. And then we will see exactly how you can implement cloud native applications and cloud native principle in Oracle Cloud Infrastructure, right? Leveraging these two types of accounts, the always free tier and the free trial account. Okay, so I hope I have your attention, because now I will have to move back to the slides. Give me just 1 second. I'm having here a lot of presentations open consoles, because I need to switch through them. And give me just 1 second to open the right one. I will stop sharing my screen for just a second. Okay. And we are live. Share screen. All right. So let's start with the definition. I think you've already heard about CNCF. Robert was mentioning. So CNCF is basically a joint effort between multiple companies, right? Where they are trying to standardize the cloud native approach and what cloud native means, trying to get in line, the different approaches towards cloud native. And of course, they have an official definition, which is quite lengthy. And I'm not a big fan of it, but okay, here it is. This is the official one. So cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid cloud, and so on. You can read it on yourself. It's on the screen there. I'm not going to cover it as it is right now, because you can read it anytime. I've added even the link to the official source. But what is important to remember from my point of view, that CNCF, it's a sub-foundation of the Linux Foundation. So when we're talking about cloud native, we are getting a lot of similarities when it comes to the Linux Foundation. And basically, cloud native appeared when the Kubernetes version 1 was released. Kubernetes, which is an open source container cluster manager, we are going to cover. It was distributed to the Linux Foundation, and basically this is their first project. Nowadays, we are going to see that there are a lot of projects being driven by the Cloud Native Foundation. So what I try to do, I'm trying to come up with a much simpler version. Of course, Cloud Native is an entire concept, so you can create a lot of definitions, but for me at least, this is the most simplest and straightforward. So Cloud Native is a development methodology designed with the cloud, for the cloud, that uses loosely coupled services that can scale. So we were not talking about cloud native before the public cloud appeared, right? That's very important to understand, that cloud native has some key characteristics which we can identify whenever we talk about cloud native, and doesn't matter what is the definition. We can identify that cloud native is mostly container based, right? So containers are responding to the question how I can build portable apps to run across systems. I think if you're not familiar with what containers are, they're quite similar with virtual machines. But here the approach and the big difference is that a container packages up code and all its dependencies, so applications runs quickly and reliably from one computing environment to the other, right? So you can migrate very easily the containers from or move the containers from one environment to the other. That's a huge thing, and it's important when we run, for example, across multiple public clouds. So a Docker container image is a lightweight standalone executable package of software that includes everything you need to run an application. It has the code runtime, it has the system tools, it has the system libraries, it has the settings in itself. So multiple containers can run on the same machine, and basically they're sharing the OS kernel with other containers, but each is running in an isolated process in the user space. The advantage is containers take up less space than VMs. Container images are typically, I don't know, tens of megabytes in size. They're quite small and can handle more applications and require fewer VM and operating systems. So there are advantages. I'm not saying, their containers are replacing entirely the virtual machines. The virtual machines are still being used, and it can be the best way to accommodate an application, or depending on the requirements of that application. But again, when we talk about cloud native, we're talking mostly about containers. Second characteristic is the microservices. So microservices are defining an architecture that structures the applications as a set of loosely coupled collaborating services. Each service has its own characteristics, and this means that the service is highly maintainable and testable. So again, we're talking about decoupled services. But it is loosely coupled with other services, so enables a team to work independently the majority of the time on that specific service without impacting the entire application, right? So there are advantages on microservices and why you would use a microservice architecture when you're developing a new application. Of course, you need to communicate. So you have loosely coupled services, but the services need to talk between each other. So you are basically using services like HTTP, right? I'm using protocols like HTTP, via REST services or AMQP. There are a lot of services which handles that communication between different microservices. So the second characteristic of cloud native is the usage of microservices. And I have the third one, which I think it was covered by Robert also, with the focus on automation. It's the usage of CI/CD. So when we're talking about cloud native, most of the time we're talking about automation and continuous monitoring of the application itself. This integration comes from the entire life cycle. It's from integrating and testing phase to delivery and deployment. This is very close, with the concepts of site reliability engineering and the concept of DevOps. This is basically saying that with CI/CD, the development, the operations teams are closely working together. So if I would have to sum up everything we were discussing about cloud native here on this slide, I would say that according to me, cloud native is a development methodology. So it's not an application. It's not it can be a framework, but it's more than this. Is a concept. And we have these three main characteristics. We're talking about containers. We're talking about microservices which work together, and we talk about CI/CD, right? So a high level of automation through the entire life cycle of the application. I assume everyone is familiar with Netflix. This is why I chose this example. So basically, when they started their business, they had basically unique requirements. How are you going to be delivered to your customers, which are globally, they are scaling globally? How are you going to deliver the best experience? How are you going to make an application to scale to, I think, millions or tens of millions of users worldwide, right? So they were not talking at that time when they identified the problems they are facing. We didn't have basically the term of cloud native. Cloud native appeared as a result of a development, and Netflix was one of the first who came up with this. Basically, if you want to check exactly back in 2013 what kind of requirements they identified for their platform, you can check their presentation from 2013, and you will see that it resembles a lot what they identified at that point with what we know about cloud native today, and what are we presenting as a guide to scale the applications to global reach. Okay, so we are talking today about microservices and cloud native, but back in the days, not so long ago, we were talking about monoliths, and there are this we tried basically to group them. We have monoliths, which are the legacy applications. We have the microservices next to them, which is basically the way we develop applications nowadays. And the next step would be serverless, and we're going to cover serverless very, very soon. And you can see that if you're comparing different things regarding these three approaches, there are some big differences. So, for example, what is one problem with the monoliths, with one big application incorporating all the functions, all the functional requirements of the application itself? The release cycle, if you think about it, it's quite slow. With microservices, because we are talking about decoupled microservices, we have a fast release cycle, which enables us to respond much quicker to specific needs. When we're talking about serverless, that happens even faster. With serverless, you are working on a function. You change the code, you can just deploy it, and that's going to be happening in production, because the entire orchestration, entire management of the function is going to be handled by the service provider. Management, right? So for a monolith, that's really interesting. The monolith, the management part and administration of the application itself, it can be simple, or it can be, I don't know, it can have a higher level of complexity. But if you compare it with microservices, from my experience, when you're starting to build applications which are really going to scale, when you're building applications which are going to become quite complex, that's going to be quite difficult to manage. Why? Because you can have a lot of microservices. It can be developed in different programming languages. So when it comes to making sure that everything works together very, very smoothly, it can be quite tricky. For serverless, again, you don't have to handle that. The service provider does it for your own name. And I'm just picking some of the characteristics here on the slide because I think they are the most obvious, and it needs to be highlighted. So for example, the environment. The monolith has its own environment, right? The application runs in its own environment. With microservices, we can run in shared environments. This means we can optimize the cost, but we can still keep the security of the application in a quite good shape. In the case of serverless, right, the environment, it's not your problem. The service provider handles that, and also the security of the application itself, of the code running, it's handled by them. And of course, the scalability. So when it comes to monoliths, the scaling part is maybe the biggest caveat. When we're talking about microservices, that's very good. We have examples for companies for, I don't know, having in production tens, thousands of microservices, which can scale based to their needs, based to the peaks of the usage of the application, and so on. With serverless, again, it's handled by the service provider, so it can scale very quickly. It's not your problem as a customer how how this is basically managed. You as a user, you are basically sure that the application is going to scale according to the number of transactions which are being initiated, and it's going to deliver the same level of user experience. And workloads, right? With monoliths, what kind of workloads are you going to have? This is quite predictable. You know what kind of applications you're going to deploy. With microservices, you can have a lot of services running in your cluster. And again, we were talking about an automation layer. So if we think about what we've listed here on the slide, these tasks can be split between developers and operations in a traditional model, right? But we are talking about it together in the context of a DevOps, because these teams together are basically working to be sure that the application works smoothly through the entire life cycle of the application. And this is very important. This was the third characteristic of the cloud native services, in my opinion, and this is what we're going to see. So cloud native applications. What you have in front of you, we are talking about CNCF. It's called Cncf Landscape. And you can see here that there are, initially when CNCF appeared several years ago, there was one project, right? Kubernetes. Right now, there are a lot of services. So getting me back to the previous slide, we were saying that, you know, the management part and the deployment complexity can be medium, even to low to medium. And even the code complexity, again, can be medium. That's because there are a lot of tools nowadays on the market, which allows you to build your applications. And we have here several categories, several pillars, right? So we have projects coming from CNCF, which handles the data management part. We have multiple projects which are covering the streaming platforms, right? So we have their cloud events. We have a NAT server. There are a lot of projects there. So you as an architect or you as a developer, when you start thinking about how your application is going to look like, you need to make some choices. And you know, it's going to be quite complicated to make the best choice directly, considering that there are so many services available there, and you can use them because they are part of an open source initiative. Again, we have, for example, in the application management space, we are talking about Kubernetes, but there are other orchestrators available there in the space. When we talk about storage, when we talk about even the runtime of the containers, there are multiple options which can be used. And of course, as Robert already mentioned in the previous presentation, infrastructure automation. There are so many tools. We are relying on Terraform for infrastructure as a code, but we are offering basically plugins for Chef. We are providing support for Salt. So again, there are multiple options. It depends on what is your use case to choose the best tool. And I don't want to scare you, right? So this is why CNCF, seeing that, you know, there is a complexity around building cloud native applications, they came up with this cloud native trail map. So as you can see here, there are 10 steps, right? Everything starts with containerization. So how I'm going to put my application inside the container. I've built my code. I need to put it inside the container. Then okay, it's fine if I do this manually, but the second step would be to do it in an automated manner. And this is why we are talking about CI/CD as a second step. Third, okay, how I'm going to manage this in production. If I'm going to talk about one container or two containers distributed between two hosts, then it's going to be fine. But how can I scale? How can I make sure that the services are up and running? That's the point when we talk about orchestration and application development. And again, there are a bunch of steps here. And this is why when we are talking with customers who didn't start to work with cloud native, the initial reaction is, oh, this is quite complex. And we wanted to come up with a solution with this sample reference app in order to help them, to guide them through this journey, right? So there are 10 steps defined by the CNCF, right? We try to put everything together in the 5 phases. We call this the cloud native for the enterprise, and basically is covering the specific this very specific subject. How are we adopting cloud native in the enterprise? It's great if you start from the beginning, if you don't have an existing application, but how do you start pushing in an enterprise environment a cloud native approach? And if you're going to check the report, I have the link on the slide. It's very interesting. In around 20 pages, you can understand what is Oracle's approach when it comes to adopting cloud native. We have basically 5 phases, right? So again, phase number 1, put your application inside the container and implement the CI/CD pipeline in order to do it in a smart way, right? Second stage, orchestration observability. I have my applications in containers, how I'm going to run it in production, how I'm going to make sure that everything runs smoothly, and how I'm going to monitor this. This is the second stage. Third stage, I think everyone is talking about this, service meshes, right? So when you decouple your applications and have multiple services speaking with each other, how do you handle or how do you monitor the communication between those? Are packets being lost? Is the communication up? What is the bottleneck if the performance of an application is not good enough? How do you try to debug and how do you try to identify where the problem appears? And then you are going to use the service meshes. Phase number 4, it's of course about distributed databases and storage. Data needs to be persistent, not always, but most of the time, in the end, you will have a data store somewhere where you need to store the data. So how we are going to do this when you are talking about loosely coupled microservices? And we're going to cover this immediately. And step number 5. Step number 5 is actually, if you ask me, a sort of others, because there are a lot of things here. Things like from best practices and how the cloud native patterns should be implemented depending on what your application requires, to different services like serverless, right? Which change the paradigm of what we discussed so far. So I highly encourage you to check this this cloud native for the enterprise, because what we're going to see and basically the application and what the demo itself is basically going to follow these 5 steps. Let me check quickly if we have some questions in the Q&A section, because I would like to take some of the questions. Okay, so if you have questions so far, please put them in the Q&A and I will try to respond as soon as possible. Once I've seen their question, I will try to pick it up. So I'm going to continue with the slides just in order to start sooner the demo part. So phase 1, containerization and CI/CD. And I'm basically discussing this because I don't know exactly the level of the audience. If you already started your cloud native journey and you are well advanced, right? So you are just trying to optimize several stuff. Again, our reference application is putting together the best practices. So I think you can use it as a demo. You can use it, I don't know. And again, if you have other questions besides that, you can always come to me, come to Robert, come to the entire team. But because there are still in the market some customers, some partners who haven't started to speak about cloud native or to try to develop using the cloud native approach, I'm going to present very briefly what each step means. So coming from the code, right? So I have a Git repository, for example. Okay, if I'm going to have a source control for my code, right? Using a CI/CD pipeline, I can take that code and build basically the Docker containers or put the application inside the container. Of course, on the slide, you will see Oracle Cloud Infrastructure, but again, it doesn't have to be. We have a very, very powerful platform here, and we can basically, with our Oracle Registry, we can host the Docker containers in our public cloud. And you're going to pay only for the object storage, but again, this is another story we're going to cover quite soon. And the CI/CD pipeline, it takes the code from source, and it basically ensures that in an automated manner it can deploy it. Even to the deployment, it can be the entire pipeline can be automated. So this is phase number 1. If you have your code available, the first thing would be to start to try to put manually the code in a Docker container. And in our reference app, I'm going to show you we have that. We have the Docker files showing you, for example, how you can build your containers. That's phase number 1. Moving on to phase number 2. Okay, PowerPoint is playing with me. Okay, I need to restart PowerPoint. Give me just 1 second. So moving to phase number 2, and this happens more often than you might think. Whenever you're trying to speak with a customer about cloud native, we often heard, okay, we will use Kubernetes. Okay, that's great, but what you're trying to do doesn't matter. We are going to use Kubernetes. Kubernetes solves everything. Kubernetes is great. Orchestration, container orchestration is a great thing. And again, it's not only Kubernetes. We are highly supporting Kubernetes because it's the leader in the market, and it's basically the orchestration tool, which is having hundreds and thousands of workloads in production. But Kubernetes is not always the answer. So we need to ask the right questions in order to come up to Kubernetes. But in phase number 2, we were talking in phase number 1 that we put our code into into containers, and we have our containers. The question is how we are going to handle several tasks. So for example, provisioning and deployment. Are we going to do it manually? If we're going to work on a server, then that's fine, you can do it manually. But what if we're planning to again, to scale and to have thousands of users connecting to our systems? How we are going to do that at scale? It can become quite difficult, and I think you know that human mistake is seen very often in production. So this is why I would like to automate this, or to have a sort of tool which does this on our behalf. How we are going to configure it, how we are going to handle the configuration when we're going to have so many containers, and how you're going to schedule, for example, the scaling, right? So maybe during the evening, you don't need to scale a lot of containers or to have a lot of pods running in production. But there are certain moments in time when you need to scale, right? So how are you going to do that? Are you going to do it manually, or are you going to let a tool to do it for you? How are going to be basically the containers be provisioned in your cluster? So you have a cluster with multiple hosts, which means multiple physical machines, right? Just for reliability purposes. How are you going to do basically the allocation between those nodes? Are you going to do it manually? If yes, okay, this can be done, but it's going to be quite complicated. How are you going to make sure that the container is running and it's available to respond to the queries? Again, scaling, load balancing, and traffic routing. How are you going to make sure that you know the requests are ending up on the right pod? How are you going to monitor that the pod is not only running but it's healthy and is able to respond to queries? There are a lot of things which, if you would have to do manually, then I think it's going to be quite difficult and impossible. And this is why we are talking about an orchestration, right? So container orchestration is the automation of all aspects coordinating and managing containers. This is very simply put. Container orchestration is focused on managing the lifecycle of containers in their dynamic environments, right? And I've managed already several times Kubernetes, but it's not only Kubernetes. We have OpenShift, we have Docker Swarm, but again, Kubernetes is the most used, and I think it's the most mature platform at this point. So if you're planning to choose one orchestration tool, I don't think you're going to make a mistake if you choose Kubernetes. So in a software engineering context, you know, declarative programming means that you write code to describe what the program should do as opposed to how you should do it. So if you're scripting it, you're basically presenting the system how you should do it. With Kubernetes, we're talking about declarative programming. So what Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation, right? In Kubernetes, we are using configuration files that tell the container orchestration tool how to network between containers and where to store the logs. The orchestration tool schedules the deployment. So basically, all Kubernetes is solving the problems we identified earlier. Why it is important and why we are relying a lot for this presentation and not only on our sample reference application, because in the source code, you don't see only the code in which each microservice is built. You see also the configuration files for Kubernetes. You see there the Docker files, and in the demo part, we are going to go through those and basically explain the steps you need to take. That by the end of the presentation, you will be able to create your Oracle trial account and do the same steps on your own. I don't know how do you learn, but for me at least, when I try to get acquainted with a new technology, I'm always trying to follow a tutorial or an example, and this is why our reference app is a great resource. Okay, Kubernetes handles the orchestration of the application, and it basically monitors if the pods are running and if all the infrastructure is up and running, if you want. But how do you measure basically the performance, or how do you measure the activity, or how do you keep track of the activity of your application? And this is the point where you start adding some extra services on top. And we are using Fluentd in our demo, and Fluentd is basically responding to the question, how do I put all the log data collected together, right? So when I'm going to have a problem, how I'm going to be able to check that each piece of my architecture is running smoothly. And this kind of logs and metrics and traces, these three topics. Basically, those are the toolkit of site reliability engineering. And in case you haven't heard what site reliability engineering is, this is something which appeared prior to the DevOps movement, when the first team of software engineers was tasked to make an already large-scale sites more reliable, and it has to be efficient and scalable. So the practices they developed responded so well that other tech companies, this appeared at Google, so other tech companies adopted the concept, and those were brought together and into a new practice set, if you want, to the table. So right now we call it site reliability engineering. The thing with adopting cloud native, and this is one of the biggest problems, the adoption of cloud native and cloud native development practices presents new operational challenges. So today's microservice environments deployed on container orchestration platforms such as Kubernetes are polyglot, right? As our application are distributed and are container based. So in order to understand the interactions among components of your system, you must be able to follow the life cycle of a request across distributed environments. And we are going to see that. We are going to see how we are going to use Fluentd to log the activities. We are going to see how we can use Prometheus in order to capture the time series events. And how do I figure out where exactly I have a problem? Then we're going to rely on open tracing. And just a fun fact, I mentioned already that Kubernetes was the first project. The second project was Prometheus. Why it was Prometheus? Because it's a vital part. How do I measure, or how do I make sure that everything, it runs smoothly and I don't have any kind of problem? So we need basically to have this kind of metrics, and this is why Prometheus appeared. And you can use Prometheus to check the data itself, but if you want to see it in a visual, in a beautiful way, in an appealing way, in order for you to be able to make this kind of drill downs and to be able to understand it in a very simple way, then we are basically relying on Grafana. There are multiple tools, but you will see Grafana in our demo application, right? The Grafana is a tool which allows you to create beautiful dashboards, starting from the data collected by the application or from the cluster and so on. And we go to phase 3, right? So service meshes, and I think everyone talks about service meshes today. It's not only in the context of cloud native applications. Service meshes are being, promoted today by VMware, so it's not exactly a cloud company. But the service mesh itself is quite interesting, and it responds to some of the problems being identified by adopting a cloud native approach. So a service mesh manages all service-to-service communication within a distributed, potentially microservice-based software system. Again, in the context of DevOps, as I mentioned, we have a quick release cycle, and we have a huge number of applications. How are we able, without touching the code, to keep track on what is happening in our cluster, right? How the communication goes between different services. And this is why when we're talking about service meshes, we have this kind of functionalities associated with the function mesh. So service discovery, what services are running in my service mesh, what services are running in my cluster. We have the service routing part. Service routing means basically how do I make sure that my requests are going to the right application, to the right microservice, to the right endpoint, if you want. Observability, okay. I don't want to spend too much time on implementing in the application itself, the logging part, the keeping track exactly of how many HTTP requests were sent and so on. So what is the simpler way to do that? And we have also the service security. How I'm going to encrypt basically the communication between different services. And I need to keep track on the time. Okay. So the simple solution for this is service proxy. So service proxies, basically, you have this kind of, you have in front of you on the screen, we have this kind of architecture, which is called the service proxy. Service proxy is a sidecar. It's basically something which runs next to the pod, and it's a proxy which handles all the communication with the container itself. By doing that without touching the code, we are able to abstract the complexity from the application itself, and we can handle the functionalities like, again, service discovery, traffic management, load balancing. We can implement circuit breaking patterns and so on without having to touch the code itself. So this is the most popular way to do it. And we talked about how we put the code into containers, how we deployed containers in productions, and how we make sure that they communicate with each other in a good way. But what about data? So historically, we have been building large monoliths application using one data store, and these applications and data store become difficult to maintain and unresponsive to change over time. They are designed for steady load, not for hyperscaling, right? So this can be true for the traditional solutions. This is why, you know, this kind of database, different kind of specialized databases appeared. So each database is specialized for a specific workload nowadays. We have the document store, we have the JSON, we have the key value, the analytical database, and so on. This is basically what we see today in different applications. And there is a big but here, right? Each single purpose database that is deployed fragments the overall data architecture. So you don't have a single, or actually you don't have a single way of managing the entire data, because it's split between different kind of databases, and that's very difficult, and it's very challenging to keep a single source of truth. Single purpose databases requires basically application to use proprietary APIs. So it's very difficult to adapt my code from one database to the other. Those are the problems which we are facing when we are talking about cloud native and building microservices, which are going to use different data stores, right? And because of this, the database management for cloud native application is difficult. And integrated fragmented database to create a complex and available, secure and scalable solution is complex and requires custom code. If you need high performance, multi-model database radically simplifies data management for cloud native. And because we are Oracle and because we are the leaders of this segment, we are basically introducing we are introducing, and here I'm talking about, although there is not mentioned on the slide, we are talking about a converged database, which is the Oracle Autonomous Database. So far, I think you've noticed that I haven't spoke anything specific, very specific to Oracle. I was speaking about the general terms, but when it comes to databases, you know, we need to speak about the leader. And think about a database, a converged database, which is able to handle any kind of interactions. This is why we call it a multimodal database, and this is why our autonomous database is a unique proposition. In our demo, what we're going to see, we are using an autonomous transaction processing, which basically handles all the interactions with the platform. Being autonomous, you don't have to manage anything, or you don't have to do the DBA things associated with installing a database. The entire provisioning is very easy. So even if you don't have at this point any kind of experience with Oracle databases, you will be able to deploy our application flawlessly with just few single clicks. And also we are supporting, you know, Oracle REST data services. This is a big differentiator. So this one tool, Oracle REST data services, fits into microservices architecture, and it's not only when we're talking about autonomous. It's available for any kind of Oracle databases. So Oracle has a small footprint application, which is called ORDS. And using this, you can enable auto REST, for example. So based on the structure of the table, you can create REST services, and you can interact with your Oracle database only with REST calls, right? So you don't need to have any kind of client or sort like that. And this is very powerful, considering that we also have this database which is able to handle any kind of data. And probably what is going on in your head, it's something like that. I was talking a lot, and I promised I'm not going to talk a lot. So this is why I'm going to hurry up and try to jump to the console as soon as possible. So this is a big picture of what we have. What are the services available right now in OCI for for cloud native purposes and DevOps. And what we are going to do now, before taking a break, we are just going to start with some of them. So we have Kubernetes as a cluster, right? And let me show you directly from the console. Right. So in case this is the first time when you're seeing Oracle Cloud, if you haven't logged in or you haven't registered your own account, this is, the landing page. And just to brag a little bit, this is the number of regions we have available now, and we have the plan until the end of the year. We are going to become probably the service provider, the cloud provider, public cloud provider with most regional presence in the world. So I'm using here Frankfurt, and there are several other regions available in Europe, but we have a very strong presence across the world. And again, if it's the first time we are interacting with Oracle Cloud, let me try to zoom in a little bit. I'm going to go here to developer services. So here you can see Kubernetes cluster, which is a managed services for Kubernetes. Everything you need to do in order to provision a Kubernetes cluster in Oracle Cloud and start using Kubernetes is to follow some very basic wizard, which handles even the networking part. And what you're going to end up with, you're going to end up with a fully running Kubernetes cluster. The management nodes is basically handled by Oracle. All you have to do is to handle basically the worker nodes. So here with different node pools, you can create virtual machines or even bare metal hosts, which are going to host basically the pods and the workloads, the applications which are going to deploy in a Kubernetes cluster itself. Very important to remember, this is you're not paying for the management part, you're paying only in Oracle Cloud for the infrastructure underneath these node pools. And this is why, besides the functionality of the service, this is a very, very strong offering in the Kubernetes space. Sorry for that. So the provisioning part is quite simple. Then what you can do it either from the console or from the CLI, because we have a fully functioning CLI for Oracle Cloud Infrastructure. You can go ahead and scale if for some reason you want to manually scale it, adding more compute power to the cluster, you can easily do that. Or if you just provision and you're playing for the first time, and this is going to be the case if you're deploying the sample reference app, then you can go here to OCI Quick Start. You just need to access your cluster. You need to copy paste this one in your CLI, and this is going to configure basically the access to your Kubernetes cluster. And then you have kubectl configured to start playing with your Kubernetes cluster. This is one very important service. The second one, Docker Registry. I was mentioning that we are supporting basically a store where to host your images, right? So your containers can be hosted in Oracle Cloud. And this is very important because when you're going to provision it in your Kubernetes cluster, the data should come in a very quick way, right, from the store itself into production. And we are using the object storage, which is highly performant. And let me go here back to developer. I'm going to go to developer services, take a look at container registry. And what we are going to see here, you're going to see that I have a lot of repositories, and here I'm hosting a lot of applications. Out of which, let me search for the one, where is it? This one, Cloud Native Subscription, right? So this one is basically a Docker image, but this is not created or uploaded by me manually. This is created by functions, by Oracle functions. So we are going to take a look how you can start from code. You can basically use FN or Oracle functions to basically put the code inside the container, absolutely automated, and it will end up running in production in Oracle Cloud, right? But keep in mind, we have this service which is based on object storage, which holds basically your Docker images. Okay. After you put basically, and you have your store to host your Docker containers, we are talking about functions. Functions, I mentioned it already. It's a simple way to go from code to run it in production without handling the management part, and we are going to take a look at that. Besides that, we have streaming, and we are using basically streaming. We are using streaming in our application. Let me take a look at that. You can find it here under analytics. If you go to streaming, we are using streaming, which is used basically as a message queue, right? So we are handling the orders part of our application. using the streaming. And again, it's a fully managed service. You just need to declare the value required for throughput and for read throughput and write throughput, right? Depending on how many messages you are going to publish or how messages you are going to retrieve. And that's it. You can use it as a message queue. And in our sample reference app, we are using this also. Okay. Events and API management. Let me take a look again at the clock. Okay, I think we have time to explain it at least. Events, so all these kind of actions happening in the Oracle Cloud, and not only in Oracle Cloud, they are triggering and they are leaving some marks, if you want. There are these kind of events. So very popular in adopting a pattern right now. It's event-driven architectures, which means basically that if something happens, I'm going to trigger an event. So for example, if I'm going to upload directly or through an application an image in the object storage, this is a very common use case, then because I identify that something was created in the object storage, I can create or invoke a function, for example, to change the resolution of my image. Or I can invoke a function to move it from one region to the other. I can copy it, delete it. I can do any kind of preparation or any kind of I don't know, any kind of changes to that or using that data source. And of course, we have the API management. Again, API management is a fully managed service. So our functions are being able, once they are provisioned in Oracle Cloud, they can be invoked via HTTP. They can be invoked using different SDKs. They can be invoked using, for example, I don't know, the Python SDK or stuff like that. We have a bunch of SDKs available for the popular languages. But API Gateway does another very nice thing. It creates a service, it creates an endpoint in Oracle Cloud under which you can basically deploy multiple deployments, right? So for example, I can take different microservices and put it in the back of an API gateway. Creating an API gateway is very simple. Let's take a look at this one, which is used by our application. So here, after I'm configuring an API gateway, what I'm going to see here is the host name, right? So when I'm going to invoke one of the services behind this API gateway, I'm going to use this one. And I just need to append the path to the specific endpoint. So let's take a look at what we have here. We have the newsletter subscription. So I'm using basically the API gateway. Whenever I'm creating a new account for a user in our reference application, I want to basically subscribe to the newsletter, for example. And this is handled by a function, and I'm going to show exactly how it works in the bigger picture of the application. But keep in mind, we have the API gateway, which is a great service to respond to functions, and not only it can stay in front of any kind of HTTP request, right? Okay, Oracle for DevOps. We have Visual Builder Studio. Visual Builder Studio, it's an integrated platform for all stages. So if you have a development team and if you want a platform to, I don't know, to handle the source code for your applications, if you want to have build machines in the cloud and basically to build your code somewhere in the cloud. If you want to have, I don't know, this kind of Scrum approach or to have this kind of boards, this is related with agile development, you can use Visual Builder. And let me show you that. I hope I'm still connected. Right. So if you're connecting to Visual Builder, this is how it looks. And I've mentioned that this handles the complete life cycle of software development, right? So let me choose a project, which is this one. And what you can see here, we have different options, right? So if you want to store your code in a Git compatible repository, then you can do it using Visual Builder. If you want to build your code, then you can do it. If you want to, for example, connect this one to one of the Docker registries where you're holding your containers, then it's supported by Visual Builder. If you're going to handle the development part, so for example, if you're going to have this kind of agile approach by creating, I don't know, Scrum compatible or Kanban boards, you can do that. And what is very important with this Visual Builder tool, which is a huge differentiator, is that the tool itself is free. You just pay for the infrastructure which is allocated to the build machines. So if I'm going to go here to organization, I'm going to take a look at virtual machines. So virtual machines are basically the machines which are provisioned in Oracle Cloud, which are going to handle the build of your code, right? If you're going to create a new VM here, I don't know, let me call it, go here to virtual machine templates. And I'm going to create a new template, make IT. Okay, I want to configure the software. So this basically it's a virtual machine, which is going to be developed, which is going to be provisioned in Oracle Cloud. And you can choose basically, what kind of software should be there included, depending on what you're going to use that virtual machine. And this is it. You're paying infrastructure cost for this. So this is a very, very strong selling point when it comes to Oracle Cloud and the services we have for developing cloud native applications if you want, but not necessarily cloud native applications. It can be any kind of application. Okay, I'm running out of time here. Let me go here and basically check the what other services we have. So we are talking about telemetry and monitoring. These are embedded services in Oracle Cloud Infrastructure. We are talking about logging, which was just recently made generally available, and I think I can show you that in our application. Our functions are already logging using the Fluentd service implementation using in Oracle Cloud, and of course we have Prometheus and Grafana. And when it comes to databases and infrastructure available in OCI, we have basically the autonomous database. What we don't have on the slide is the autonomous JSON database. And what we also don't have on the slide is the recently announced MySQL service, which is very, very strong. And I urge you to go and check it out. It's very powerful. And one more thing, developer tools. So we are trying to offer support to any kind of developers. This is why we're supporting with SDKs most of the popular languages, including .NET. We have support for Terraform. We have support for Ansible, Chef, Salt, and this kind of very popular tools used by the developers. And again, there is a huge push from our side to develop and enhance all the functionalities we have. And that's it with the theoretical part. We will jump to the console, but not before a 5-minute break, I think. Yeah, we can take a 5-minute break. How you can start using these resources. So for example, if I'm going to go here, I'm going to have the two options. The always free is the basic one. And why it's always free? Because I think it was already mentioned. For each user registering for Oracle Cloud account for life, we are offering some resources for free, like 2 virtual machines, 2 autonomous databases, which can be used forever and so on. So the basic one, if you start playing with it today, you can play it, I don't know, for the next 10 years if you want. But the other one, the Kubernetes deployment, which requires a lot more resources and is going to be closer to what we will use in production. This again can be used for 30 days by using the Oracle free trial. I'm going to explain the options you have at the end of our presentation. What else? So here you have detailed descriptions about the components included and what you need to do step by step. It's not a problem if you don't have any kind of Oracle Cloud infrastructure experience, because we are basically covering in the documentation that part as well. So we will have to start by creating the identity credentials if you want, and resources. You want to create a compartment, and you want to create an API user to interact with your cloud account. All the steps are detailed in the documentation, right? After that, you need to start the setup part, and this one depends according to what scenario you are going to focus. You can start with the deploy one, or go with if you have already, for example, Kubernetes experience. If you are familiar with already what a deployment in Kubernetes means, then you can go ahead and play with the complete version of it. And also, if you check the documentation, we have some extras. These are completely optional. So for example, if you want to deploy the Istio service mesh, okay, this is going to be provisioned using the demo profile. So again, it's not ready for production if you want. In Istio, you need to do a lot of tweaks and customization if you want to have it production ready. But it's a very good starting point if you want to experience with it. And let me go here, try to zoom in a little bit. Okay. So let's take a look. Those are basically the folders, and these are the resources which are in our Git repository, right? So let me start with source. And in source, what you're going to see here is basically the source code for all the modules you've seen in the complete picture of the architecture. Let me go back to that. So for example, I'm curious to see, for example, what is the, how it's, I don't know, how is the catalog being implemented? How is going to connect to the ATP database, right? This is a very, I don't know, interesting use case. How I'm going to write in Go an application is going to connect to ATP database. Then what you can do is to clone our repository and check basically the source code. We have here everything. We have the source code. We've made publicly available, for example, the Docker files, right? So basically, you have all the resources required in order for you to start playing with the source codes what we have. So in the source code folder, you're going to have everything you need in order to start experiencing from developer point of view, playing with this application. Okay, let me close the source folder. And again, if you really are interested to start playing with Cloud Native, this is a very, very good resource. It's a hell of a job delivered by our Oracle A team, because you can find a lot of information regarding Cloud Native, regarding different services, but it's very rare that you're going to find everything put together to have it as an application which can be easily deployed and start exploring, what is the logic behind that application, how that application was built, and how you can put everything together. Okay, if you want to implement CI, again, we have the code here. And again, after you have the source code and you start understand the application and what the application does specifically, if you're not a developer, you can skip that part because the application is already packaged in the containers, and we have the part in which we put basically the application in containers here under deployment. And I was mentioning there are two deployment models, the basic and the complete. For example, and this is very important, if it's the first time when you are playing with Docker, you never used containers, it really doesn't matter. You can use this Docker file and follow the documentation. Basically, you have a README file here in which it explains basically what are the steps, what are the commands you need to take. You need to give me a second. I'm trying to zoom out a little bit. Yeah. So basically in the README file, you have all the steps required in order to take your code, which is already there, and put it in a Docker file, in a Docker image. At the end, you will end up with the images locally. If you want to build it locally and run it locally, as you can see here, I don't have the images locally because I'm using the repository in Oracle Cloud. But again, if it's the first time when you're interacting with Docker, if you want to, it's the first time when you try to package an application, then you can check the Docker file. And under basic, under the basic folder, you can see here the guide, and you have also the source file. What is a Docker file? Let's take a look at it. So basically, this Docker file, it explains how the source code is going to be taken and being incorporated in a Docker image container, right? So you can see that it's quite easy to understand. So we are using a base image, which is this one from Node 12-Alpine storefront builder. Please use this kind of these are some commands which are passed to Docker in order to build the applications when you build the Docker image. I'm copying basically the source code from our folder, which is src/storefront package, right? I'm copying it inside the container, and I'm running some commands inside it. It's quite easy to understand. The Docker file, the syntax for Docker file, it's quite easy, and it's very well explained in the Docker documentation. So if it's the first time when you're doing that, use this one without any kind of emotions, let's say. It's very easy to do. Okay, the basic deployment was handling the part in which you are taking your code and put it inside an application, right? And this is what we do with Docker file. We will end up with Docker images. But then we want to automatically provision the infrastructure deployment, right? So we will have the virtual machines, we will have the autonomous database, and this is done automatically with the use of Terraform. If it's the first time when you use Terraform, similar with Kubernetes, this is a declarative tool. I'm basically saying, using these configuration files, let me check the autonomous, the database part. No. Okay, let's take a look, for example, load balancer, right? So I'm saying via these configuration files that I want to configure a load balancer, and the load balancer in Oracle Cloud is comprised out of multiple things. It's comprised out of the load balancer itself, and I'm declaring here that I want a resource. The type of resource is going to be an OCI load balancer, and I'm going to name it the resource in Terraform mushop_lb, right? And then I'm going to say I want to have it to have another load balancer backend set. This is a construct coming from Oracle Cloud Infrastructure, and you just declare the values according to the specifications of the Terraform provider, right? This is, again, if you're playing for the first time with Terraform. If it's the first time when you're playing with Terraform with, I don't know, infrastructure as a code, you can use this one as an example. And if you're going to follow documentation and run it, this is what you're going to end up with. You're going to end up in Oracle Cloud Infrastructure, fully functional with this deployment. If you're going to take a look one by one, you will find all the services and all the configuration in that basic folder, right? Under Terraform, you will find all the resources being provisioned. Of course, again, it's very well documented. You can take it one by one and start playing with Terraform if you want. We have here some scripts, for example, how you're going to kickstart basically the virtual machines and so on. It's a very useful resources if you're starting to play with the infrastructure as a code and Docker containers. And this is the basic part, right? So I already said that we have two versions. This is the simple one, and you can use it with the always free resources, because it's going to provision only 2 virtual machines, 1 autonomous database, which is again under the always free resources being offered to you. So that's it. That's very easy. But if you want to go one step further and to start really playing with Kubernetes, and if you want to start learning, I don't know, deploying Istio and how you can use Prometheus and so on, we can take a look at the complete version of it. So what we are going to find here under complete, we have different folders, right? So Terraform, I already told you what Terraform is. It's an infrastructure as a code. Basically, in this one, if you check the configuration files, you're going to see that this is way more complex compared with the basic deployment. And this is because using this one, you can end up with the entire cluster and everything, all the entire mushop being provisioned automatically. Seriously, it's very easy to be done. You just check the documentation, follow the step, configure the prerequisites, and using this Terraform script, you can basically deploy everything with the single command, Terraform apply, and everything is going to be handled by yourself. So basically, this is the highest level of automation we came up with when creating mushop. And if you are a really experienced user, you can check this out in order to get acquainted with, this high level of automation. But you can take it also one by one. So if you want to learn Kubernetes, you can go here and check basically the Kubernetes itself. Kubernetes itself, again, it's I already told you that it's a declarative programming method, if you want, in which you are saying, look, these are the services, or this is the resources I want to provision, and Kubernetes is going to handle that on its own, right? So you can see here that when we check on the code in our mushop deployment, we have here, for example, different kind of services. So we have ingress, right? We have what else? We have secrets. So secrets are basically handled to store passwords, for example, in a protected way. This is regarding the configuration variables of your application, and this is why you would create a secret. And yeah, let's take a look at our cluster, for example. Let me scroll in a little bit. Okay. So in order to interact with Kubernetes, you're using this tool, kubectl, and again, part of the documentation is how you create the configuration file for kubectl. That's very easy because it's handled by the OCI CLI instrument, this OCI CLI tool. If you want to check, for example, the kubectl get nodes, right? Okay, let me have a little higher level of info, right? So what I have here, I'm using the kubectl command to understand exactly what are the nodes being deployed in my Kubernetes cluster. And if I'm taking a look at the IP addresses and the characteristic and everything, and go back to my OCI services, here under Kubernetes cluster, you will quickly understand that we are basically connected to this cluster, right? Let's take a look at the node pools. So we basically have a node pool of 3. And if we check the nodes, you are going to see that those are the IP addresses of our IP addresses being assigned in Oracle Cloud when creating the Kubernetes cluster. So basically, we are connected with kubectl to this cluster, right? Okay, what else? Let's take a look, for example, at the load balancer. And in Kubernetes, there is this kind of construct which is called services. So if I want to get the services, again, this is not the scope of this. The scope of this presentation is not for you to learn together, because it would be impossible to do it together in 1 hour and a half. But what is really important is for you to understand, what are the resources we are providing to you, and basically you can go ahead and follow step by step. If after this presentation you have any questions, feel free to come back to us, and we can work together. For example, on your application, if you are struggling to take your application or develop a new application and put it in Kubernetes, come to us and we can work together on that. So there is this construct, the resource type of called services. And what you can see here is that basically we have provisioned a load balancer type. And this one is the public IP address, which we are using to access our Mu shop, right? So this load balancer, it was provisioned by Kubernetes and it's registered in Kubernetes as an entry point to the cluster. And you can see here that it is basically being handled by Istio. And we will get to Istio in a bit. Okay. Let's take a look at what deployments we have in our cluster. So if you're going to follow the same steps according to the documentation, what you're going to end up with, you can see that we have the Mu shop API, the Mu shop assets, and basically those are the services running in the back of our Mu shop applications, right? So these are running in our cluster, and yeah, we are relying, for example, what you can see here is an OCI service broker. So the service broker, it's a plugin, if you want, which you install in Kubernetes, and on your behalf, it's going to provision the Oracle Cloud Infrastructure resources automatically. Again, this sounds and can seem quite difficult, but to be honest, it's very easy if you take the documentation and follow it step by step. Okay. What else? We took a look over Kubernetes and Helm. Helm, it's another abstraction layer, right? Helm, it's like a package manager for Kubernetes, and basically using Helm and Helm charts, you are deploying the Mu shop. I'm not going to get into details of Helm, because again, it can become quite complicated. But let me do something else. Let me do something more graphical, or something which can be easily to understand. Let's take a look at Istio, right? So Istio-ctl. Again, I was mentioning that dashboard. I was mentioning that this. Oh, okay. I need to export it. Give me just 1 second to add it to the path. This is completely optional. So if you don't want, for example, to if you don't want to deploy Istio, you don't have to. But if you're going to, we put it there as an extra. And if you want to, start using Istio, you know, that's a very good resource. You can basically, after before deploying the new shop, you can use Istio in order to have your service mesh up and running. And this is what you're going to see. This is Kiali. This is a dashboard for Istio. And let's take a look, because I think this is very, very interesting. Let's take a look at the graph. So I was trying to explain the theoretical part. What is the role of a service mesh? But I think, you know, here you can see it much clearer. So using Istio and using the service proxies, what we are able to do, we are able to track the interactions between our applications, right? Our microservices, actually. So here, for example, if I'm going to click on the API and I'm basically drilling down to the traffic which passed by through the API microservices the last 7 days, you are going to see that, you know, there are some statistics here regarding the traffic sent and traffic received. Of course, I don't have a lot of traffic here in the system, but imagine that you are going to have a much broader picture if you're going to have a production system here. The data is going to be really, really interesting. Let me show you another things which you can do with Kiali and Istio. Let's go here to workloads. And let's search for what? Let's go to API. I think we were looking at API. Right. So I selected the workload, which is the API microservice here. And if I'm going to go to logs, okay, I don't have any logs here. I would need to generate some traffic on the application to have some logs. But you can here you can have even the you can have the you know, the logs which are generated by the application. You can see the pods which are running in details. Of course, this data can be obtained also from Kubernetes itself. And you can see, for example, the services which are registered to serve these pods, right? This is why you would use Istio, and not only for that. It provides service encryption without changing the application code. It provides service discovery, as we discussed. So again, using service mesh is a really good idea, especially when we're talking about very complex applications. Let me check the time. Okay. Let me go back. This is one of the dashboards. And again, this is because if you follow the documentation, you install the default profile of Istio. And these components are basically, okay, close the connection here. These components are being provisioned automatically for demo purposes. If you want to provision it, for example, Grafana, and if you want to have Grafana installed, you can install it either manually or customize the deployment. What we are using today here, it's just a sample in order for you to understand what is the usage of a specific tool. Let's take a look at what? Istio-ctl, Prometheus. We were saying that Prometheus is the second. Okay, I was checking the chat. I was saying that you know, Prometheus is used basically to store the metrics coming from the application. So if I'm going to check here on Prometheus the graph part, let me check if it's it's broken pipe. What we can do, for example, for a specific metric, and again, I'm not going to get into details, you know, how Prometheus, what is the querying language and everything. But for example, if you choose a specific metric being collected by Prometheus, then you can, let me check if I have something here on API server. Okay, application cards, saver time, 15 minutes. Okay, so for example, because I don't have any kind of workload on the application, I have only one entry, but Prometheus would save basically all the entries which are generated by the application. And here you can see that I can log, you know, the specific metrics coming from my application depending on my business needs, right? So this is how you can use Prometheus. And of course, you can put and output this data in Grafana in order to have it presented in a beautiful way. Okay, and one last thing, because I've mentioned functions a lot, let me take a look at here. So under functions in my source code, what we're going to have, it's a simple JavaScript application, which is using basically the SDK which you need to use in order to invoke functions and to basically push functions towards Oracle Cloud. And this is a simple application which is going to register my user and send him a confirmation email. This is already provisioned, and this is behind an API gateway, which I already showed you in Oracle Cloud Infrastructure, right? So if I'm going to invoke it manually, because I was saying that, you know, we put this in the back of an API gateway just in order to understand, just in order to be able to invoke it using pure HTTPS requests, right? So what is going to happen when I'm going to make an invocation towards it? What is really important, and check it, that you know that the response time it takes quite a time. This is why, because you know the function was not invoked, and because it was not invoked, it's not in an active state running in the cluster. But once you call it the first time, it's going to get preheated if you want, and it's going to respond much faster. Of course, this is in order to, if you think about it, take a look at this. If you think about it, that's in order to keep costs under control. So with serverless, you're basically paying for just the execution time, and it would be no reason for you to run the application before having a really need of it, right? Okay, if I'm going to go back to the console and check the functions, resources, developer services, it can be found here under developer services, functions. Let me go to cloud native. And we have this newsletter subscription. This is exactly what we were invoking from the CLI. Of course, you can invoke it from the browser itself, or any kind of environment which can consume HTTP requests. Okay, and this is going to take a little bit of time, but as you can see, we are being able to monitor here the number of invocations, right? So I invoked it 5 times, and in the dashboard, it's showing me that this function, it was invoked 5 times, right? And now it's being able to respond very quickly. I can monitor here and basically log the entire. I can log the activity of the function without any kind of problem, and generate logs which can be added in the logging service. I'm taking a look at the clock, and I know it's a lot of content, but again, just to sum up, we were talking about MuShop, and this is a reference application. This is an application which can be used by you. Take the source code, follow the documentation, and implement it on your own. You have 2 options in order to get started with Oracle Cloud. You have the always free account, and I don't see any reason why you would not register your own always free account and start using it. But there is also, for bigger workloads, we have the 30-day free trial option, right? So you receive an amount of money, $300, and you can start developing. You can start basically provision resources besides the ones which are always free. So for example, if you want to play with Kubernetes, this is the simplest way in which you can deploy a Kubernetes cluster, start playing with it in Oracle Cloud Infrastructure, and why not maybe even to provision and to deploy the MuShop. Okay, so just a brief description of what is always free. Compared with other public cloud services, we are actually offering quite a lot. We know we have the autonomous database. There are 2 instances which can be deployed, compute, storage, and so on. Yeah, so let me take a quick look, because I know we are running out of time. Let me take a look if there is any Q&A, if there are any questions in the Q&A section.
Still no question in the QA.
Okay, if there are no questions, okay, if someone wants to address any questions now is the good time.
I believe that our audience is a little bit tired.
Yeah, I assume. I assume.
A lot of information from you.
Yeah. I know it's quite complex. This is why we try to, and actually, thanks for noticing that. It's a very complex topic. It's a broad topic. It's very difficult to cover it in 1 hour and a half. But also, this is why we came up with this reference application. You know, it's going to make things much, much easier. And that's the biggest differentiator. And I wanted to go together only through the resources we have available, right? Please use that. And if you have any kind of questions, don't hesitate to come back to us.